So, geology. Geology. Geo earth, logia study, derived from Greek word. Therefore, in general, geology can be defined as the study of earth. Father of modern geology James Hutton's 1726, Scottish geologist. Hutton devised one of the geology's fundamental principle of uniformitarianism, which says that the same natural processes we see operating today are the ones that have always operated, and that these everyday natural processes have shaped our world. Tony Hagen, first Tony Hagen, first geologist, 1979, United Nations Program Economic Minerals, 1950. People who study geology is geologist. The study of earth's its origin, history, composition, structure, together with the nature of process that involve to form rock, so also known as earth science. Branches of geology: pure geology and applied geology. Branches of geology: historical geology, history of earth; physical geology, internal and external agencies and various processes such as wind, water, glacier and sea waves that bring about changes on the earth's surface. Structural geology, structures present in rock. Crystallography, arrangement of atomic structure, shape, etc. Mineralogy, mineral composition, characteristics, occurrence. Petrology, from Greek petra, rock, and logos, knowledge, rock type, properties, origin. Geophysics, concept of physics used to determine subsurface geology. Geochemistry, bonding of minerals, ratio of composition. Hydrogeology, groundwater movement and geological process of surface water. Historical geology, history of earth, reconstruct. The principles and techniques of geology to reconstruct and understand the geological history of earth. So here is the time scale. Physical geology, internal and external agencies such as energy, wind, water, glacier, and sea waves were acting inside and outside the earth that brings changes on the earth's surface. Structural geology, forms of rock, strain and stress distribution. Crystallography, branch that deals with the geometry of crystal. Arrangement of atoms in the crystalline solid. Here is figure of some rocks and crystals. Mineralogy, definite chemical composition, origin and formation, classification of minerals, geographical distribution, utilization. Petrology, from Greek petra, rock, and logos, knowledge, rock type, properties, origin, usage. Petrography, study through microscope. Petrogenesis, origin and formation of rocks. Geophysics, geophysics is the branch of geology in which the principles and methods of physics in the field of geology. Generally, gravitational method, magnetic method, seismic method, electrical method used in the field of geology. Geochemistry, study of chemical composition of earth, bonding of minerals, ratio of composition, determination of age of rock, dating, exploration of minerals. Hydrogeology, groundwater movement and geological process of surface water. Study of landforms in geomorphology. Study of landforms, tectonic, limestone, volcanic, wind, river, Sir glaciers. Environmental geology. Application of geology in the field of environment. Economic geology. Ores, construction metal having economic value. Paleontology, that is fossil. The study of the forms of life existing in prehistoric, historic, or geologic times as represented by the fossil of plants, animals, and other organisms. Engineering geology. Application knowledge of geology applied in the field of civil engineering for the construction of infrastructure. Engineering geology. Applications of geology applied in the field of civil engineering for the construction of infrastructure provides the use of geological data for practical engineering purposes. IAEG, the science devoted to the investigation, study, and solution of engineering problems which may rise as the result of the interaction between geology and the works or activities of man, as well as the prediction of and development of measures for the prevention or remediation of geological hazard. IAEG stands for International Association for Engineering Geology. Scope of engineering geology in the field of civil engineering. To gain knowledge of construction material, its occurrence, composition, durability, and other properties. To gain knowledge of the geological work of natural agencies such as water, wind, ice, and earthquakes helps in planning and carrying out major civil engineering works or projects. To understand the occurrence and movement of groundwater, depth of groundwater table, etc. To gain knowledge of subsurface, soil and rock type. Identify different geological hazards like earthquake, flood, landslide, etc. To identify the appropriate site for the construction of infrastructures like road, tunnel, dam, reservoir, multi-storied building, etc. To gain knowledge about erosion, transportation and deposition of sediment river system so can control soil erosion and provide mitigation measures. If the geological features like faults, joints, beds, faults, solution channels are found, they have to be suitably treated. Hence the stability of the structure is greatly increased. The knowledge of geological agents like water, wind, glacial helps in planning while carrying out civil construction. Identification of erosional land and depositional area. The foundation work of civil structure are directly related with art. Mitigation of different natural hazards. Geological information helps in planning construction project. To recognize potential difficult ground condition prior to detailed design and construction. To minimize the risk factor, probability of failure. To reduce the total cost for the construction of infrastructures, engineering works. Dam construction. So here is a figure of down. So here is the figure of reservoir water for the condition of favorable and unfavorable. So you can see here. For the favorable this and for the unfavorable this. So here is a tunnel and some figure regarding the construction for the civil engineering. Importance of geology in civil engineering. Major work of civil engineering. Aim. Construction. Infrastructures, road, bridge, tunnel, irrigation canal, airport, reservoir, high-rise building, etc. Type. Safe, durable economy, where your ground, earth surface. Knowledge. Study of engineering geology. Engineering geology in the field of infrastructure development. Why? Safety and stability planning, precaution and economy, successful construction. Geology plays the vital role in the field of civil engineering. Civil engineering is a branch of engineering that deals with the design, construction, and maintenance of roads, bridges, large buildings, airports, ports, subways, dams, mines, and other large-scale development. Geology helps in the selection of appropriate site for the construction of any civil engineering structure durably, safely, and economically. Landforms. So landforms, orogenesis. Landforms are the natural shape or features. Landforms on the surface of the earth, or a landform is any physical feature of the earth's surface having a characteristics recognizable shape produced by natural causes. Mountains, plains, silt, plateau, valley, coast, etc. Mountain. land mass on the earth's surface that is higher than the surrounding land around it, generally steep and higher than a hill that is greater than 600 meter, else called hill, formed by folding and faulting of earth's crust by plate movement and the volcanism. It is a slow movement of huge landmass, mountain range, mountain system, mountain chain. Mountain may be tectonic mountains and residual mountains, tectonic mountains, formed by tectonic activities of the earth like plate movement and volcano, generally formed at plate boundaries. Types of tectonic mountains: fault mountains, volcanic mountains, dome mountains. Fault mountains formed by the relatively displacement of the blocks or plates along the boundary. Sierra Nevada Horse Mountains. Fault mountains formed by the folding of the Earth's crust or called block mountain. Himalayan range. Volcanic mountains formed by the eruption of the volcano. Example: Mount Helens, Mount Pinatubo, etc. Dome mountains. When magma allows to push upward instead of eruption cools below surface. So here is some figure of mountains related to volcano. So residual mountains. Mountains formed by the weathering and erosion of different rocks of the earth's crust. Due to erosion, soft rocks are worn down into sand and hard rocks are left standing up in the area. Major mountain ranges of the world: Antarctica, Africa, ASEAN, Australia, Europe, North America, South America. Antarctica, Antarctic Peninsula, Transantarctic Mountains. Africa, Atlas, Eastern African Highlands, Ethiopian Highlands. ASEAN, Himalayas, Tauros, Elbrus, Japanese Mountains. Australia, McDonald Mountains. Europe, Pyrenees, Alps, Carpathians, Apennines, Urals, Balkan Mountains. Northern American, Appalachians, Sierra Nevada, Rocky Mountains, Laurentides. South American, Andes, Brazilian Highlands. Shield, a large area of exposed Precambrian igneous and high-grade metamorphic rocks, is an old and stable part of continent in which the basement rock crops out at the surface, is overlain by sedimentary rock and sediment. The shield was formed by tectonic forces. Mountain building was at one time far higher than any mountains presently on earth. Over its long history, the shield was worn down by erosion and now is nearly flat with rounded hills of rock. Example: Canadian Shield. Plateau, large island area of fairly level and land separated from surrounding land by steep slopes. Example: Tibetan Plateau. Valley, valley is a hollow or surface depression of the earth bounded by hills or mountains. Hills, hills are elevations of the earth's surface that have distinct summits but are lower in elevation than mountain. Coast, a coast is an area where the ocean touches the land. Plain, low lying, relatively flat with minimal relief, usually formed by the deposition of sediments brought by rivers. Average height is less than 200 meter. So this was for today. Thank you.